Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. Hey, this is re-recorded for 2018. This is section 8.1. I'm going to re-record all of chapter 8, it looks like, because I just didn't like the way they came out before. So I'm going to, let's start right now. Chapter lesson 8.1, graphing quadratic functions. This really comes down, these first few lessons in chapter 8 are going to really come down to more like transformations. So I'm going to review that a little bit. And our first question here is, what are the characteristics of the graph of the quadratic function of the form f of x equals a times x squared? Well, hopefully you recognize x squared as being the parent function, and a, we're multiplying that output. What does multiplying the output mean? Well, let's talk about that in a second. This is from the book. It's got a lot of words in here. I redid it as this example. So let's talk about this example here. It says, consider the graph of the quadratic function. Using the graph, you can identify characteristics such as the vertex, axis of symmetry, and the behavior of the graph, as shown. So vertex is kind of like the low point or the high point. The shape of this graph of a quadratic function we call a parabola. And the high point or low point is called the vertex. This line down the middle, it's not part of the graph, but these parabolas, they're symmetric. And the line around which they are symmetric is called the axis of symmetry. We can see also from this graph that the domain is all real numbers because it's going to, the x values will continue to decrease or increase. They cover all that way. We can also see that the range is going to be based on the vertex. The range is all real numbers greater than or equal to -2 in this case. And then we can also see that when x is less than -1, because our axis of symmetry is x is -1, this is our axis of symmetry. If it's less than that, then the function decreases. Those y values get smaller and smaller until we pass that line of symmetry, in which case the y values get larger. So we say the function is increasing. Okay. So there's kind of a lot to take in right there, just in terms of how we can describe this parabola, this graph of the quadratic function. And then next I have this old friend. We did this earlier in the year, but I want to make sure that if you didn't have this in your notes and you're not comfortable with this, that you are comfortable with it, because we did it for linears, we did it for exponentials, and now we're going to do it for quadratic. So I'm not going to go over this in detail, but it's here in case you need to get this into your notes again. And hopefully you have this learned by heart by now. But if not, here it is again, and you can get this in your notes. So we're going to go back to that question about a times x squared. So hopefully you remember, if we multiply the output, a couple things going to happen. We can either stretch or shrink it vertically, and we can also reflect it over the x-axis if we have a negative number. Okay, so if it's a number greater than 1, it's going to be a stretch, and that kind of goes back to what we said over here. So we're multiplying the output. If it's a number greater than 1, it's a vertical stretch. If it's between 0 and 1, in other words, if it's a fraction, a regular fraction between 0 and 1, it's going to be a vertical shrink by that factor. And if it's opposite, if it's a negative number, it's going to be a reflection over that x-axis. So this part here is what we're kind of looking at today. Okay, so let's take a look at this first example, graphing a x squared when a is greater than 0. So we want to graph 2 times x squared and compare it to x squared. So hopefully you can see that this is going to be a vertical stretch greater than, a vertical stretch by a factor of 2. And what is that going to look like? Well, here's our old friend Desmos. So I'm going to first put in here x squared. So there's our real basic parabola. And now I'm going to multiply that by 2. So 2x squared. So this vertical stretch, you can see it kind of makes it look skinnier. It makes it look narrower, but what's really happening is that this point here, let's say at negative 2, 4, well, now it's at negative 2, 8, right? Because we're multiplying the y value. Oops, should have done that. We're multiplying the y value by 2. So everything doubles. So not everything, I'm sorry, the y values double. So here at negative 2, 4, we get negative 2, 8 up here. Okay, that's a vertical stretch. And now we're going to multiply by negative 1/3. So negative 1/3 times x squared. Let's take the negative off first, so we can see that this shape is like shorter. It's more like a bowl. Let's say it's shorter because what's happening is all of the y values are being reduced by 1/3. So where we had something by up here at negative 2, 4. Well, now it's going to be negative 2. Now 4 is being multiplied by 1/3, so it's 4 4/3 or 1 1/3. So down here at 1 1/3 is where we're going to see that negative 2 and 1 1/3. This is an approximation, something like that. There you go. Okay, and then of course multiplying it by a negative 1. It reflects it over the x-axis, which we've seen before. Okay, so all of these transformations are real familiar to you, hopefully. Let's take a look at this last word problem here. The diagram at the left shows the cross-section of a satellite dish where x and y are measured in meters. Find the width and depth of the dish. Well, just by looking at the diagram here, okay, we can see that the width is out here at negative 2, 1 and 2, 1. That's the width. So what's our width here is going to be the difference between those points, or you can just say 2 plus 2. The width is 4, or you can think of it as 2 minus negative 2, right? The difference, 2 minus negative 2 equals 4. And then the depth, well, the depth is from, again, that line up here down to the low point here. The low point's at 0, 0, and the high point is up here at 1. Well, the depth is 1. So we're just really still looking at the parabola and looking at those characteristics. And that's all I have for you. I'll see you in class. Thanks a lot. Have a good rest of your day. Bye.